Hello my dear friends, I am Sujoy and today I will tell you how to do operation research assignment problem with a minimization problem. Assignment problem is of two types, one is minimization problem and other is maximization problem. Today we will focus on minimization problem. Our question is solve the following assignment problem and find optimal cost of assignment. The basic funda of assignment problem is that there will be a grid of numbers. This is called cost matrix and 4 persons are there, A, B, C and D, and 4 machines M1, M2, M3 and M4. If we assign machine 1 to person A, our assignment cost will be 1 unit. Similarly, assigning machine 2 to person A, cost is 4 unit, machine 3 to person A, cost is 6 unit, and machine 4 to person A, cost is 3 units. Similarly, for B, assigning machine 1, machine 2, machine 3 and machine 4 to person B, cost will be 9, 7, 10 and 9 units respectively. Our objective is to assign different machines to different person, 4 machines to 4 person in such a way so that our total cost of assignment is minimum, since it is a minimization problem. So let's start. Step 1. Getting 0 in each row and each column. To start with assignment problem, we need at least 1 0 in each row and each column. To get that, if there is not at least 1 0 in each row and each column, we need to take the lowest element of each individual row and subtract that element from every element of that row. That is called row operation. And do the same process for each individual column, and that is called column operation. What that means? That means scan each row for the smallest element. For row 1, the smallest element is 1. So we will subtract 1 from each of the elements in row 1. So 1 minus 1 is 0, 4 minus 1 is 3, 6 minus 1 is 5 and 3 minus 1 is 2. So we will get 0, 3, 5 and 2 in row 1. Do the same to row 2. Smallest element is 7. 9 minus 7, 2. Here 0. 10 minus 7, 3. And 9 minus 7 is 2. So 2, 0, 3 and 2. Perform row operation to each of the rows. Ultimately you will get our new matrix. Now we will again scan each column to check each column has at least 1 0 or not. So you can see that the third column has all non-zero numbers. We need at least 1 0. So we will perform our column operation. Same process, finding smallest element in column 3 is 3 and we will subtract 3 from each of the elements in column 3. So we will get 2, 0, 4 and 0 in column 3. Now we have got our new cost matrix to start the operation. Step 2, drawing lines to cover zeros. Draw lines horizontally like this way or vertically but not diagonally to cover maximum number of zeros with the minimum number of lines, and the first line will be drawn to the row or the column which has maximum number of zeros. So we see that in row 2 there is 2 zeros and row 4 there is 2 zeros. Again in column 1 2 zeros and column 3 there is 2 zeros. So we can start our drawing lines from either row 2, row 4, column 1 or column 3. We will not draw lines to row 1 since it has single 0 and row 3 since it is at 1 0. If number of zeros collide, that means there is same number of zeros in any of the 2 rows or any of 2, 3 or 4 rows in a bigger problem, then you can draw line to any of the row or any of the column which has same number of zeros. So we will draw our first line, row 2, that is L1, and our second line to row 4 and our third line in column 1 to cover all the zeros in the matrix. Step 3, test for optimality. If the number of lines drawn, 3 number of lines are there, is not equal to order of matrix is 4, the solution is not optimal, then we have to recalculate our cost matrix. So for optimality, take the smallest element from the uncovered elements and subtract that from all the covered elements. These are uncovered elements, that means any lines has not gone through these elements, and find the smallest number among the uncovered elements. So smallest number among the uncovered element is 1. So we will subtract 1 from each of the uncovered elements. And next second rule is that and add that element with intersection elements. These are intersection elements. 2 lines intersect at this position. 2 intersection elements are there. So we will add 1, that is the smallest element, to intersection elements. So we will add 1 to this, we will get 3, and 1 to this, we will get 4. And we will subtract 1 from each of the uncovered elements. So we will get 2, 1, 1, 0, 3 and 2. And remaining elements through which only a single line has gone will be kept untouched. performing the above operations, you will get our new matrix, that is our recalculated matrix. Again, step 4 is read all lines. Again, same process, L1 through R2 since it has 2 zeros, L2 through R3 since it has 2 zeros, and L3 through R4 since it has 2 zeros, and our fourth line will be through column 1 since it has 2 zeros. Now again checking for optimality, since number of lines this time is equal to order of matrix 4 lines and order of matrix is 4, so it's an optimal solution. As we have got our optimal solution, now in step 5 we will find our optimal allocation. For that we will write our optimal matrix below without the lines, and for allocation scan each row and each column to check in which row or which column we have a single zero. So we can see in row 1 and column 4 there is a single zero. In rest of the rows and columns there are 2 numbers of zeros. So we will start our first allocation either in this position since it has single zero, or in this position. So personally I will start with this position. Allocation means covering that element with a block. Once we have allocated this location, that means allocated machine 1 to person A, we will cross all the zeros along that column and along that row. So there is a zero in the first column, so we will cross that zero. That this zero cannot be assigned to any other numbers. Next, again we will scan for single zero, 2 zeros, there is a 1 zero, this zero is crossed. So our second allocation will be done in this position, and we will cross our this zero is already crossed along this row. Again scanning, here is a single zero, this zero is crossed. So our third allocation will be done in this position, and we will cross this zero for this allocation. And finally we have this zero is left, so our fourth allocation will be done in this position. This is our optimal allocation, and now we will find our optimal assignment list. So person A is assigned machine 1, person B is assigned machine 3, person C is assigned machine 2, and person D is assigned machine 4. Next we will find our optimal assignment cost. For that we will see in the original matrix A M1 position, A M1 position. In our original matrix A M1 position there is a value 1. So for A is 1 plus B M3, B M3 is 10, C M2 5, and D M4 is 5. So by assigning or allocating machine 1 to A, our cost is 1, machine M3 to B cost is 10, machine M3 to M2 to C cost is 5, and machine M4 to D cost is 5. Adding all this, our optimal assignment cost is 21 units, and this is our required solution. How was the video? Tell me in the comment section, and if you like the video, please like it using the like button, and subscribe to my YouTube channel. You will be notified by email whenever I upload my next video. I uploaded a complete series of tutorials on this Casio FX 991ES calculators on different modes, how to use all the modes. Mode 1 is computational mode, mode 2 complex number mode, mode 3 statistics mode, mode 4 Bayesian mode, mode 5 equation solver mode, and mode 6 matrix mode, mode 7 table generator mode, and mode 8 vector mode. If you own this calculator, you can watch those videos. Also uploaded another video on 20 cool features of this simple calculator Casio FX 822MS. If you own any of the calculators, you can watch those videos to know how to use your scientific calculator to the fullest. So I am signing off for now. Thanks for watching.